also have non-equality joins. These are just joins wherein in our where clause, we are using any comparison other than the equality condition. Or from the in from clause, using join on with a non-equality condition. Before we go to our example, let us first condition the following scenario. Justly Books offered a week-long promotion in which customers receive a gift based on the value of each book that they purchase. The gift and the purchase value that qualifies for the gift are provided in the promotion table, as we can see below. If the book purchase is between $0 and $12, the customer will get a bookmarker. If it is between $12.01 and $25, they will get a book label. If it is between $25.01 to $56, they will get a book cover. And any book value 56 and above, they will get free shipping. As an example for non-equality join, we would like to determine the gift that the customers could receive for any of the books currently represented in the inventory. And take note, we're going to get the title of the book and the possible gift that they were going to get. The title of the book will be coming from the books table, and the gift will be coming from the promotion table. As you can see, we are joining the books table and the promotion table. But our join condition is that the retail price should be between the minimum retail in our promotion table and the maximum retail in our promotion table. This is an example of a non-equality join. And the results we can see on the right. This one is the same implementation of our previous example, but this time we are using the join on keyword. We have seen in an example before that we may be saving the employee number of an employee's manager or an employee's spouse in the same table. If you would like to get information on the manager or the spouse, we need to do self-join in our table. Since all of the column names are ambiguous, self-joins require qualification of each column using table aliases. In the Justly Books business model, we are interested in customer referrals. That is why for each customer in the customer table, we are also storing the customer number of the referring customer in the referred column. In this example, we would like to list the customer ID and customer name of those customers who were referred by another customer. We also want to include the ID and the last name of the referring customer. Again, we need to use table aliases for us to prevent ambiguity. We use the table alias C for the customers and the table alias R for the referring customer. And we are getting the following information. For the customers, we're selecting the customer number, customer's last name, and the customer's first name. For the referring customer, we're getting that referring customer's customer number and customer last name. And we can see that we are joining the two tables, or we are self-joining the customers table to itself using the following condition. C that referred should be equal to R.customer number. And the results we can see on the right. Let's take a look at another example of self-join, but this time using a non-equality condition. In here, we would like to list the customer number, the customer last name, and the city for each pair of customers located in the same city. In here, we are joining customers by itself And we are using F and S as our table aliases. As we can see in our join condition, we are joining them using a less than sign, but greater than sign will also work. We are not using a not equal because if we use a not equal, we will just be getting the same pair, but just interchange. In our previous examples, we are joining the tables based on equality, and we are disregarding the records in each of the table that do not have a matching record in the other table. But what if we have a case wherein we want to get all of the records even if we don't have any match for that record? For this case, we are going to use outer join. Outer joins include all rows that are correctly matched plus the rows that do not have a match in the other table. The following three are the types of the outer join. We have the left outer join, the right outer join, and the full outer join. In the left outer join, we're getting all the unmatched rows from the table on the left. In the right outer join, we're also getting all the unmatched rows from the table on the right. For the full outer join, we're getting all unmatched rows from both tables in our left and in our right. The following is an example of a left outer join. In this example, we are listing the customer number and the customer name. For each of those customers that have placed an order before, we are also including the corresponding order number. As we can see in our output at the right, we have the details of all our customers. And if they have ordered before, we are also including the order number. And for those customers that do not have any orders before, we are still getting their details, but we are leaving the order number blank. So that's what we mean by a left outer join. We're still getting all of the details in the left table, even though they do not have any match in the orders table. So how are we going to do it? In our select statement, we can see that we are joining the customer C and orders O, wherein our customer number is equal to the customer number in our orders table. But we have a positive sign in our customer number to signify that this one is a left outer join. The following SQL statement accomplishes the same thing as what we have done in the previous slide. Only this time, we have used the keyword left outer join and then using. Alternatively, we can use left outer join and then on. And then we specify the column names for which to compare the values. Again, we're going to use this, especially if we don't have the same name for our columns.